kiddos. Welcome back. We are in our final week of Unit 8. We have covered up to this point 2 teaks, and this is our last teak this week. We're still talking about impacts to Earth systems, and specifically this week we're going to be focusing on our water system. All right, so your TEK this week is 7.8c, which simply states the student is expected to model the effects of human activity on groundwater and surface water in a watershed. And so we're going to take it back a little bit and we're going to bring back everything that you've learned previously about the water cycle. So you got to remember it's a continuous cycle that's constantly replenishing the fresh water here on the Earth's surface. Key concepts. Thinking about the previous 2 weeks of what you've learned, the first week that when we started Unit 8, we focused on the slow changes to Earth's surface, specifically talking about the processes of weathering, erosion, and deposition, and how they work together to shape the Earth and to change the Earth over time, slow changes. And the second week in Unit 8, we focused on catastrophic events and how they can affect the ecosystems here on Earth. So pretty much like those fast changes, things that can happen instantaneous with those catastrophic events. And so this week we're going to focus on natural events and human activity can impact Earth systems such as found in a watershed. So in addition to that, we're going to talk about, well, what is a watershed? And we'll look at the relationship to groundwater and aquifers. All right, so natural events, just for keeping this in the back of your head as we're looking at this show, this little PowerPoint says examples are catastrophic events and changes over time naturally. Okay, hurricanes, tornadoes, even wildfires that are natural. Think about how a tornado can impact your water system. Keep in mind what you've learned about weathering, erosion, and deposition as well. Human activities and what we're going to be looking at are examples of ways that we affect our water. So things like pollution and contamination, fertilizers and chemicals, as well as overuse and wasting and overpumping when we're talking about wells. All these things can affect our water. We're going to start with some vocabulary, okay? So the first word that you need to be familiar with is the word porous. And porous simply means that it's a surface that has holes or pores and it's able to soak up water. So it's kind of like a sponge. So any material that is able to absorb and soak up water, we would say that's porous. A synonym or another word that is the same as porous that you will see out throughout the videos that we're looking at and the reading passage that we have on STEM Scopes this week. The word is permeability. Basically, permeability is the measure of the soil's ability to permit or to allow water to flow through it. So if you look at the two pictures here, the picture on the left, you can see that those have bigger pores or basically bigger spaces between the sediment pieces there, so the water is able to flow through it more easily. So the looser the soil is, or the bigger the pores are, the bigger the spaces are between your pieces of sediment, the more porous it will be. The picture on the right shows you dense soil. See how tightly packed those are? That will not allow water to flow through it very easily. Alrighty, so let's start and look at surface water. So if you're thinking about the water cycle, remember the surface water is pretty much everything that's on top of the earth. So you're talking rivers, lakes, ponds, oceans, springs, okay, all of the water. Now, I know when you were in elementary school and you learned how the water cycle works, you learned that 70% of the earth is salt water. Okay, so if you took all of the water that's on earth, 97% or about 97% is ocean water, salt water, water that we can't use. Can't drink it, can't use it for watering plants, things like that. Okay. Only about 3% of the water that is on the earth is fresh water. Okay. And of that 3%, only 1% of that is liquid. Most of the fresh water is trapped in icebergs and things like that. It's frozen, so it's not easily accessible. Groundwater is exactly as it sounds. That's the water that's in the ground. So if you think about like every time it rains and the water soaks into the ground, okay, this is actually a very important part of our water cycle, because under the ground, That's where we get our drinking water from. Okay. It says here, water that filters through the soil and is located under the earth's surface. So we call that groundwater. A couple of things here that you may be familiar with is like wells. So I know a lot of people out in the rural area like Quinlan get their water from running a well into the ground. So basically all they're doing is drilling down until they tap into a source of water that's there, and then they're able to pump it out and use it. It's fresh water. It's very, very clean. And then also all these pockets of water that are in the ground. This is what an aquifer is. Okay. And again, that's where we get our drinking water from. Um, you got to think about the different layers and all the layers of soil and sediment and rock. And as the water's trickling down, that's a natural filter. It's going to naturally clean itself. So by the time it gets down to where it's going, where it's kept, it's pretty clean. All right. An aquifer, here you go. This is one of your vocabulary words. Simply, it's a body of permeable rock which can contain or transmit groundwater. So this, like in this picture here, this would be considered your aquifer because it's a layer of rock that this layer would be permeable, okay, because it has allowed the surface water to drain through, okay, and it goes through, and then eventually it's going to reach a layer of rock that is impermeable, okay, which will not allow the water to run through. And then that's basically where you get those pockets of water, okay? Here's a little map just so you can see these are the some of the major aquifers that we have here in Texas. Okay, the word watershed, you will see and hear this. And basically all a watershed is, you got to think of it like a funnel, okay? Due to the force of gravity, all water runs downhill. So if you were looking at this picture here, you can see that, the water coming back through the water cycle in the form of rain, and it's eventually, due to gravity, it's going to soak in, and then there's going to be what we call runoff. The runoff will eventually make its way down to whatever body of water's there, river, stream, lake, whatever. And so all this whole area where all the water funnels to one place, this would be considered a watershed. Watersheds can be, various sizes from a small area to a very, very large area. So again, watershed is just this particular area that you're looking at where the water will funnel down to one particular spot. Okay. The word water table, which you need to be familiar with, is basically, think about this, especially if you have one of those wells that I just mentioned a while ago. If you're drilling into the ground, okay, and when you drill and then eventually, bam, you hit water that's under the ground, you've hit your water table. Okay, that's all it is. And then we're going to talk, when we get into talking about human impacts on our water system, the main thing we're going to look at is pollution. So there's two kinds of pollution here. There's what we call point source pollution. And what that point source pollution means is it's a one specific place, okay, where you can trace back and have physical evidence of the pollution that's taken place, okay? So it's coming from one very clearly identifiable site. So like the factory here is pumping this pollution into the air, which is going to contribute to acid rain because of the pollution in the air, which is going to contribute to water contamination when it comes back to the earth in the form of rain. Okay. Like this right here, there's them showing you one like this is like, it looks like a sewer pipe or something of some sort, and it's pumping right back into the river. This is a point source pollution because it's coming from one specific location. Then we have what we call non-point water pollution. And basically all that means is it's coming from a broad area and you can't pinpoint exactly where it's coming from. So like if you look at this picture here, this is a good one because like you have a neighborhood, a residential area that has many homes. Okay. And then you have a sewer system or sidewalk system or whatever, where when it rains and all the water, again, due to gravity, runs back to one particular place, it's going to pick up all the contaminants that these people have contributed. It can be, let's say you are cooking with grease in your kitchen, and then you end up with a lot of extra grease. I've known people who have gone out and dumped it like in the back of their yard or the back of their property. They'll go dump it and they're contaminating the water because what happens over time is that will seep into the soil. And as it rains and the water gets soaked up, it carries that to your aquifer. You may know maybe your dad or uncle or somebody has changed oil and they take the oil out of their car. And what you're supposed to do is collect it in a container, because there's an appropriate way to get rid of it. And you take it to a site that will get rid of it safely. But I've known people who will take it and, like I just said, like that grease, they'll take it and dump it off in the back of their property somewhere. Again, seeping into the soil, which will contaminate your water. Okay. Cities. So you got all these buildings, all this people, all this pollution. You don't know exactly what's coming from where. You may have a big farm area where you have a bunch of crops or even a bunch of animals, and animals poop. Okay. So you have that waste going into the soil. And again, all that runoff, all that water is going to go back to one particular location, and it's going to pick up any of those contaminants and take it back to that river or lake or whatever. So again, point solution means coming from one specific location and you can see where it's coming from. Non-point water pollution, it's coming from a particular area, but you don't know exactly who's contributing what. Okay, now we're going to watch this little video. This is a good one on groundwater.
Between the gaps of rock. However, only 3% of this water is fresh water, at least 70% water. However, only 3% of this water is fresh water. Much of this fresh water is frozen in glaciers. You'll find some of the water in rivers and lakes, but almost 30% of this fresh water is groundwater. But what is groundwater? Welcome to Moo Moo Math and Science and Groundwater. Groundwater is water that finds its way between the gaps of rocks and sediments underground. As the water seeps into the ground, it may find its way into an aquifer. Aquifers are large underground rock layers saturated with groundwater. An aquifer is not an underground river, but large porous layers of rock. For example, the Floridian Aquifer covers the entire state of Florida and is over 100,000 square miles. Think of an aquifer like a huge underground sponge that soaks up the water that falls to the surface of the earth. If you grabbed a shovel and started digging straight down, you may strike water. The first water you strike is called the water table. Below the water table, the rock may be completely soaked. This is called the saturation zone. The rocks and minerals above the saturation zone may be dry and is called the unsaturated zone. So how does this water end up in the ground? When it rains, some of the water moves down into the ground. If this water moves deep enough, it can stay there for a long time, like thousands of years. However, not all of the groundwater stays underground. Much of the surface water comes from groundwater and aquifers. If the ground dips below the water table, the groundwater will flow to the surface and may create a body of surface water, like a lake. Groundwater can also flow out of the water and create a stream. This is called a spring. However, some groundwater is so deep that it's difficult to get to. These bodies of groundwater are called confined groundwater. Humans depend on groundwater for drinking water and for growing crops. This groundwater can be reached by digging a well. There are thousands and thousands of wells throughout the world that provide drinking water and water for our crops. If you'd like to know more about groundwater, this playlist will help. And as always,
Okay, so we're going to back out of this video and get back to our PowerPoint. And so now that we know what groundwater is, let's talk about how we care for it, okay? So thinking about all the ways that we as humans contribute to the quality of our water, okay? Let's recap real quick. We have looked at, we've discussed that natural disasters, including floods, hurricanes, tornadoes, earthquakes, volcanic eruptions, and tsunamis, can disrupt and contaminate water supplies. Flooding and other disasters can damage drinking water wells and lead to well contamination from livestock waste, human sewage, chemicals, and other impurities. So, thinking about a flood, even a flash flood. When we have those quick rainstorms, and it brings up that rushing water over the surface, it will pick up any trash or any contaminants that's in the soil. Okay, think about wildfire fires. All that smoke is going into the air, so again, contributing to air pollution, which will contribute to acid rain. Earthquakes, busting water lines and dams and things like that. Tornadoes, just think about the debris that a tornado will spread everywhere. So, again, contributing to the quality of your water. Okay. This is just a simple diagram that shows how water will flow. So, very simple diagram, very simple model, but it's showing you that water will drain into the soil. Okay, and it will run downhill due to gravity, and then that water will lead back to some sort of groundwater discharge, a stream, a spring, something like that. And then you have out here, like this is showing you the ocean, where it will contribute to water underground from the soaking in of the ocean. Okay. This next slide is just showing you a very simple model, again, of how humans contribute to the water supply in negative ways. So the more air pollution that we create, okay, through factories, cars, things like that, that contributes to acid rain. And so when it falls back to the surface, it's contaminated. Okay. We have overuse of pesticides or fertilizers. So all these crops that we have, and the farmer will put a pesticide on it to keep the insects from eating their crops. Well, when it rains, if there's excess pesticide there, washes off, runs right back into your water. Okay. Gas leaks, or even, like I said, something as simple as taking your oil, from changing your oil and pouring it into the ground. Septic systems, when septic systems bust, okay, all that human sewer that contributes to the quality of our water. Okay. So again, just a very simple diagram. Now, before we wrap up, I have a model I'm going to share with you, because we have not really talked about landfills yet. And you can see here that landfills are a way that humans contribute to the water supply. So let me show you real quick. Okay. So again, very simple model. All I have here is a water bottle, plastic water bottle that has water in the bottom. So this would be like your aquifer, okay, the water that's in the ground. So not 100% clean, but pretty clean, okay. And then I have the top part of my water bottle that's sitting down here, and it's just full. I put potting soil in there, and then I put pieces of styrofoam and some pieces of aluminum foil in here, because this is supposed to model like a landfill. If you don't know what a landfill is, basically it's just a big hole that we dig in the earth, and we dump all of our wet waste and trash in there. Then we cover it up, and we let it set and hopefully start to decompose and break down and return back to the soil. But when we put things like aluminum and styrofoam and chemicals, that kind of stuff doesn't break down. It stays there forever. Okay. So you have a landfill. You have the rain. It comes. The water soaks in the ground. If you don't have a landfill that's constructed correctly with some sort of protective lining or something like that, this is exactly what happens. So I'm going to pour the water, and the water that I'm pouring is just simulating a rainstorm, and it's running through the soil, oh, looky there. See my water's changing color? Yeah, looky there. It went from clear to dark greenish bluish, and that's supposed to signify the contamination, the toxins, the pollution that is now in our aquifer. And that's, again, where we get our drinking water from. So that's why it's really important that we as humans, first off, quit contributing to air pollution and learn how to live greener, cleaner, because we have to take care. Remember, only 1% of the fresh water on earth is liquid water that we're able to drink. So we got to conserve it. We don't waste it, and we got to take care of it. Okay. Now we're going to wrap this lesson up, and I'm going to talk to you about your expectations for showing us what you know. It says here, I've put together Legends of Learning. So for those kiddos that feel like, you know what, I need some more information, I need to do a little bit of practice before I do something for a grade, you can go to Legends of Learning. There's a playlist. I also have a quizzes that I've posted here. Again, it's for practice. Okay. And then there's 2 activities, and you're just going to pick one. Okay. You can do the STEM Scopes passage on the watersheds, or you can do the Ed Puzzle video that covers groundwater and surface water. I do want you to realize that you can do both. Okay. Let's say you do the STEM Scopes passage and you make a 40 on it, and you're like, oh, okay, I can't afford a 40 for this week's grade, because remember, you're only getting 1 grade a week. Do the Ed Puzzle and see if you can do better. We will take the higher grade. Okay, Miss Lavelle and I both, we've agreed to this. So whichever one you do better on, that's the grade we'll give you for that week. Okay. And I'll put a little note on here. Please don't ask for me to reset your Ed Puzzle, or ask me what you can do for extra credit if you have not attempted both the assignments. Okay. That's why they're there. And I'm giving you ways to practice. So practice before you play. Okay. It'll help you. All right. If you guys have any questions, please feel free to get a hold of me during my office hours. Remember, Monday through Friday from 4 to 5. And Miss Lavelle's available from 11 to 12. I am going to give you a little side note. Just know that tomorrow, Monday, I will not be available during my office hours. I'm sorry. I have an appointment that's came up, and so I will not be in front of a computer. But just if you have a question, keep it and come back on Tuesday, and then we can talk if need be. Okay. All right. You guys be good. See you soon. Bye.